All right. So before I share my screen, if you want to unmute your mic, probably raise your hand. What is Web 2? What is, currently we are saying we have Web 3.0. What actually is Web 2? What is Web 1? Anyone? Or do you want me to call names? Do you know what is Web 2 before we move into blockchain? Okay, Ose, you can speak.
Okay, good evening, everybody. Good evening. I'll say Web 2 is, if I'm correct, I'll say the Internet of Things, where which we as humans could interact with the Internet. There was the invention of chat groups, the invention of smartphones, the invention of a platform where there could be an interaction between the web and humans, basically.
Okay. All right. Thank you. Any other person who wants to give it a shot? Balarima.
Yes, for Web2, Web2 is a kind of application platform whereby you can carry out the create, update, delete, and those features majorly for many of those web applications. So for Web1 is where they are majorly tests. You just read through, that's readable. And Web2 is where you can actually put content online, such as blogging. There's an admin page for you, and there's your normal viewers page. So that's an example of Web2.
All right, that's cool. Any other person who wants to give it a shot? Okay. All right. So thank you everyone that responded. Basically, the Web 1 is just the static iteration of the web, and Web 2.0 gives you like the flexibility of like getting, as you are communicating, you are getting response back immediately, you can interact with it. But Web 2.0 comes with its own set of challenges, which is the reason why you have Web 3.0. And Web 3.0 basically is the decentralized web. Currently, everything you're accessing is being handled by different companies. For example, you are able to use Google Meet now because it's a service being provided by Google. And we are going to go into more details about this decentralization and how it relates to blockchain. Can you confirm if you can see my screen? Because I'm already sharing my screen. Can you guys see my screen?
Yes, we can.
Yes, I can.
Yeah. All right. Okay. So we are starting with introduction to blockchain. Before I go, I like my class to be interactive, so I don't know. So I know that I'm not just speaking to myself. So I believe a whole lot of us before now, we've heard the buzzword blockchain. For some, maybe Bitcoin, cryptocurrency, and stuff. What do you actually think is the blockchain? You can drop it on the chat. You can unmute your mic. Balawa, can proceed.
Yes, I think the blockchain is a database whereby there are blocks of storage and they are linked together or chained to one another.
Thank you. Any other person? What do you think is the blockchain? Why is my class silent today? Please let our class be interactive so that we can all get the best out of this. All right. Since no one is okay.
All right. So I think blockchain is a way of storing data in chains of blocks, in which it's going to make it not easy to cheat or hack the system. So it's a very safe way of saving data.
Okay. All right. Thank you. So let's go into today's class. Basically, blockchain is just a list of records called blocks, but these blocks are linked together in chronological order. That is, the first one, the next one, it is arranged sequentially. So the good thing about blockchain is that each block stores something, and this, what is included in the blocks are what we call like transactions. So like since this is our first class, there are going to be a lot of new words, if like probably you're totally new to the blockchain, that you're going to be hearing, but it's something you can know. As if there's anything I'm saying that's not too clear, you can call my attention to it and I go over it. So these records that are being stored on the blockchain, they are stored in blocks. Blockchain, chain of blocks. So inside these blocks are transaction data. The blocks hold records, and these records are basically transaction data. We are going to come over what we mean by transaction in blockchain as we proceed along. And the good thing about this information stored is that they are all encrypted using cryptography. And this cryptography is to ensure that the privacy of the user is not compromised and data cannot be altered. So I know before now, probably a lot of us have heard about the word crypto, cryptocurrency, this thing. And for some, it might actually be Bitcoin. That was the first thing you heard, that like your first word to hear about like blockchain and stuff. What makes all these things works is actually cryptography. And I want you to know that there's actually a large difference between cryptography and encryption. So cryptography is also encryption, but its own encryption algorithm is a bit different from the way encryption works in the traditional world. Encryption basically is two-way. That is, you want to send a secret information to someone, you encode it, that is, you encrypt it using any of the algorithms available, and you send that encrypted version to someone. And for the person that you send this thing to be able to like decode what you've sent, they actually need to be on the decrypt that information, that is the encrypted version that they have. They need to decrypt it using the same algorithm that you have and using the passcode. But encryption is one-way function. I mean cryptography hash function. It is one-way function. It is non-reversible. That is, once you encrypt something using a cryptographic hash, it cannot be reversed. But the deterministic nature of it is, for example, now let's say, okay, I have Temi here. If I use cryptographic hash on Temi using the capital letter T, small letter EMI, the output that I will get will always be the same thing anytime I want to encrypt Temi again using cryptographic hash. That's the deterministic nature of it. So like we are still going to come into details about that, but I just need to like point out the difference between the traditional way of encryption and cryptographic encryption. So we are clear. So, and we have most of them, we are going to be using SHA-3, that is SHA-3, which is the hashing algorithm used mostly by Ethereum. So, and moving on with our explanation on blockchain. The good thing about blockchain is that information stored on the blockchain are not dependent on centralized authority. They don't need a centralized body to maintain them. And there are no restrictions for using blockchain because it is decentralized. When you're in a centralized system, you have to like at least meet some requirements before you can access some service, can be placed on restriction and stuff. So for example, a centralized system for a lot of us that are Nigerians. some months back, we could not access Twitter because it was not made available for our location based on some things. But that's not how a decentralized system works. In a decentralized system, all you need is internet connection and the right device, and you can plug in and access those services. Those restrictions are not available, are not achievable on a truly decentralized system. That's part of the reason why you have this iteration of the web, so that you don't have any centralized authority sitting on your data and manipulating it. That's basically why you have blockchain. So the participants of the network maintain the data, and they hold the democratic authority to approve any transaction which can happen on the blockchain network. So ideally, the blockchain most of us are open to, that we know now, is actually public blockchain. So a public blockchain operates using blockchain as a database as the core, but it is public. The reason why I use "but" here is that any transaction that has been added to the blockchain is available to everybody to see. Anybody connected on that network can actually see the details of that transaction. For example, let's say someone sent me money since, let's say, 2018. Everybody that has access to that network now can actually go back and see the details of that transaction that has been carried out. So that's it on that. So blockchain tech, okay. Fatima.
Yeah, okay, sorry, by network, what do you mean? That everybody on that network, what does the network mean?
Anybody connected on that blockchain network. So we are going to come later into that. Yeah, like each blockchain, we have different blockchain with their own different architecture. So network is like a means of you accessing those blockchain. So, but most of the time, not in all cases, it is usually synonymous together with network. So for example, now when I say I want to like carry out transaction on Ethereum as a blockchain, I can say I am carrying it out on Ethereum network. So that's it. Yeah. I hope that answers your question, Fatima.
Yes, it does. Thank you.
All right. So this blockchain technology is a structure that trusts transactional record, also known as block. So at every point in time that we are going to come later into like distributed system, distributed ledger. But the good thing about blockchain is that with the copy I have is the same thing that let's say we are on the same network now. The same copy I have is the same one that Fatima has, is the same one that Temi has, is the same one, the same data available to me is the same thing made available to everyone connected on that network. So and because of this, each transaction has to like be combined together to make up one block. So like inside a block, you have list of transactions. And this connection of once a block is fed up, another block is connected. So it moves chronologically like that. So that we have block number and stuff that we are going to come into. You as blockchain developers, smart contract developers, these are going to be like the stuff you are going to be working with in your day-to-day activities. So it's better that you like get a good grasp of this stuff. How you can speak. Yeah, I guess so. You should have access to it at the end of the class. So all right. So in case you have questions, you can drop it on the chat so that once I come back, I will go there. I can see your questions. So so How you can speak?
Yeah, I said that. You said when a block is filled up, another one is connected.
Yeah.
Yeah, I was asking, how will you know when one block is filled up?
It is not your, it's not your business as a user to like
Okay.
understand that it is being handled by the technology itself. So the blockchain technology that indexes your transaction handles that for you. So it's done automatically. So every transaction, here's what you need to know. Blockchain technology is a structure that stores transactional records. I'm going over this because I'm going to go a bit deeper now. And as I'm going deeper, like the what I've said earlier, I'm going to be building on it. So see the blockchain like a database known as the chain, and that data is accessible to everyone through peer-to-peer connection, and yeah, which is called peer-to-peer nodes and stuff. But what gives this blockchain its power, apart from cryptography, is digital ledger technology, DLT. So every transaction that you want to like add to the blockchain needs to be authorized by someone, by a digital signature that is the owner of the account. Just like when you want to like perform some transaction in your bank now, and let's say you need to sign, your signature proves that you are the authorized person to like carry out transaction, carry out actions on that account. So also in this, when you want to like perform transaction from an account, sorry, someone mic is unmuted. So sorry about that. So everybody accessing that account that wants to like perform a right transaction on the blockchain actually needs to like append a data signature to it, and this data signature is generated from a private key. If private key is confusing to you, don't worry, you are going to like understand it as we proceed. But private key, see it like the master key to your account when you want to like perform transactions on the blockchain. So, and this data ledger technology is what makes it possible that the same transaction available to one connected node on the network is the same thing available to every other person. So next we are going to go into distributed ledger, because distributed ledger is what powers the blockchain. So before I proceed to that, let me know, is there any question? Please, you can ask your question.
Okay, thank you. I just need to know the difference between the chain and digital ledger.
We are coming there. We are going to go there. That is our next part. Also your name and this list.
All right, thank you so much. I'm actually thinking the transaction you're mentioning, is it just related to financial transaction or any transaction made on the blockchain?
Okay, here is it. So it's this is like we are going to call blockchain. See it like every right action, like see it like this. Any process like you want to add to the blockchain is what is being referred to as transaction. So it's not necessarily when you like exchanging money. Any action you are performing on the blockchain that like updates the state is a transaction. I don't know who asked that question. Is it clear now?
Yeah, it's clear. Thank you.
All right. Romola, you're on this list.
Yes, good evening. So I'm a bit confused. I don't understand what you mean by where I saw peer-to-peer nodes, and I don't really understand like what exactly a peer-to-peer node.
So peer-to-peer nodes is basically peer-to-peer connection. Like we are accessing a service without any intermediary. So like, for example, now peer-to-peer connection is just you like we are all accessing Google Meet now from different devices. See it as peer. So all these peers connected on this stuff. So although when it comes to like blockchain, it's quite different, but like that's just like a basic analogy of how this peer-to-peer stuff works. Please, is your question answered now? Yes, I think.
Oh, yes, thank you. Okay.
All right. So now let's go to distributed ledger. So a distributed ledger is a database that's consensually shared and synchronized across multiple sites, institutions, or geographies, accessible by multiple people. So look at it like this. Decentralized distributed ledger is what makes it possible that each person connected on the network on using that database can access it at the same time. For example, when you are using your bank app now, let's say you deposited some money to your account while you were in Lagos, and now you move to Abuja and you want to withdraw money, and you go to like maybe one of your bank branches in Abuja to make your withdrawal. Sorry, Romola, you can put down your hand so that I don't. So you can go to your bank branch in Abuja to withdraw, and once you start apply to withdraw, they are going to check your record, and because they're not going to take it's not going to be that what you have, the amount you deposited was deposited in Lagos, you can only withdraw in Lagos. It's not going to be like that. But because it is your account, what you deposited in Lagos branch is also what is made available to the Abuja branch. That's distributed system. So like different people connected to that, using that database, connected to that network, having the same peer, the same copy, the same information being shared with them. That's basically what distributed ledger is. So like that, if you notice, like when I was explaining, I mentioned consensus and I mentioned synchronization. Consensus basically is just a way of agreement that is these different branches, these different nodes, different peers connected on this blockchain have agreed that this is the actual data that's available there. That's basically how distributed ledger works. So the participants at each node of the network can access the recordings shared across that network and can own an identical copy of it. Because it is distributed ledger, every single person connected there has that access, and that each copy that you have is authentic. It is authentic. That's how this thing work. So now, looking at this, you can now be like wondering that is distributed ledger different from blockchain, or are they the same thing? We've explained that blockchain is chain of blocks that stores like record of transactions, record of stuff stored on the blockchain. But what I want you to know is that all blockchains implement distributed ledgers, but not all distributed ledgers are blockchain. That's one thing you need to know before we proceed. So the most important difference to remember is that blockchain is just one type of distributed ledger. We have different types of distributed ledger. Although blockchain is a sequence of blocks, distributed ledgers do not require such a chain. When you are using distributed ledger, it's not necessary that you implement it on blockchain. It is not necessary. You can have your distributed ledger system, ledger technology, working on a Web2 architecture. But every single implementation of blockchain that you see makes use of distributed ledger. That's what makes their data easily accessible to everyone. And this distributed ledger, in comparison to blockchain, distributed ledger does not need proof of work. If this is your first time of hearing proof of work, we are going to explain as we proceed along. But if you like at least have a glimpse of what proof of work is, distributed ledger does not necessarily need a proof of work. And with this, they have like better scaling options. So the next one, a distributed ledger is merely a type of database spread across multiple sites. I've explained this. However, all blockchains are distributed ledger. I'm coming again on this. All blockchains are distributed ledgers. But remember that not all distributed ledgers are blockchain. Whereas blockchain represents a type of distributed ledger, it is also a merely subset of them. So blockchain is not all about distributed ledger, it's just a subset of it. There's more to distributed ledger that you can learn about. And we have different examples of that you can look into. There's Hashgraph, there's Holochain, there's Tempo, which is also known as Redis. There's blockchain, which is an example of distributed ledger. There's DAG. So, and you can go to this site to learn more about that. So, because for the purpose of this class, I'm not going to like go over like all these different examples of distributed ledger, but you can go over it for better understanding. Yeah, that's it. So like what are some of the distributed ledgers that can work with Web2? Hashgraphs is one of them. Hashgraphs is like a data structure that can be implemented for a project. Yeah. So now let's go on to the next one, which is actually we are getting into this thing. So before I proceed, I would like to, what do you think is Bitcoin before we proceed? We're not going to go into details all about Bitcoin, but it's necessary that we point out the difference between Bitcoin blockchain and Ethereum and other blockchains. So we can proceed. Or how many of us here have heard about Bitcoin, or is this our first time of hearing Bitcoin? You've heard about Jolade, you've heard about Bitcoin before. So what do you think is Bitcoin? Fatima, your mic.
Okay,
Okay, what's Bitcoin?
thank you for this
Okay.
class. It has really been amazing. So, to my own understanding, I think Bitcoin is a type of blockchain, right? The type of coin used on blockchain database, just like Ethereum, BNB, and yeah, all these other types. I think that's all I know about. Okay.
All right, thank you. Peace. You said you sold some. What's Bitcoin to you? Peace.
Okay, I thank you. I take Bitcoin as another digital currency that can be bought and sold to, yeah.
Okay. All right, thank you. Sorry. Someone's voice. Sorry, I think someone hand was raised before that. It's no longer here. Precious, you can ask.
Okay, hello. Bitcoin is a decentralized currency based on the blockchain network, blockchain technology rather.
Okay.
There's a
All right.
proof of
Okay.
concepts, and for each transaction, there's a proof of concepts before each block is released, I think.
Okay. All right. Proof of concept or proof of work?
Proof of work, rather.
Okay. All right. Not the first time Bitcoin is a coin or currency in place of physical money to carry out transaction. Okay. Thank you. So here's it. How Bitcoin came into place was we have this thing. Now we know we have distributed ledger, we have blockchain technology, which can make this make transaction accessible to everyone. It is not limited. So Bitcoin was created to be like a digital currency that enhances peer-to-peer payments, which is backed by the blockchain. So Bitcoin was actually created by a pseudonym, which as at this point, we don't know if it is actually one person or a group of people. So these people came about to like create Bitcoin as a blockchain. So this blockchain helps like has its own coin, which is Bitcoin, which serves as a payment medium to like which you can use to like perform your transaction. It has a limited supply and stuff. So the reason why I'm going through this is because Bitcoin on its own has its own limitation when it comes to like blockchain architecture. So after people like have used Bitcoin and see like, wow, this is an awesome technology to use, but we should be able to do more with blockchain technology. That's now what brought about Ethereum. So Bitcoin like has fulfilled its own like implementation, has like achieved the purpose for its creation, which is to like serve as data payment. Good and fine. But currently we need to like do more on the blockchain. We need to like, let's say, build infrastructures on blockchain, perform a lot of actions on blockchain. This is what now brought about Ethereum. Bitcoin was created not to be programmable. That is, you cannot build any additional stuff on Bitcoin as a blockchain. But Ethereum now came in place with the vision of the founder being that Ethereum should be what is being referred to as the world computer. World computer in the sense that it is accessible to everyone and you can perform transactions on it. But the added advantage of having Ethereum as compared to Bitcoin, it is that Ethereum allows you to like build algorithms, build infrastructure on it as a blockchain, which was not available on Bitcoin. So like this architecture is what enables you to like build smart contracts. So smart contracts basically are like data programs that run on the blockchain technologies such as Ethereum, Polygon, Solana, and stuff. That is what brought it. Is this innovation of Ethereum that brings about the invention of smart contracts to work on blockchain and also gave birth to the rise of different blockchains that we have in. I hope you are all on the same page before I proceed. Okay, how can I ask you a question? I hope I'm not spoiling that name the way I'm pronouncing it.
You are, but it's fine.
What's the correct pronunciation? Sorry.
It's Hawa.
Please, can you give me another name that,
Well, you
that
could
probably
just call me Nana.
Nana? Okay, all right.
Yeah.
Yeah.
I don't really
You have a
understand what you
question?
just said. Yes.
Okay. What I just said basically is Bitcoin is a blockchain. It was created to be like a form of data payment, serves like a data currency that is backed by blockchain. For example, Nana, I don't know, are you in Nigeria or outside Nigeria?
I'm in Nigeria.
Okay. For example, now in Nigeria, use Naira as your currency. So this Naira is what makes it possible that when you want to buy something, you just give that, you give them the note. That's your own way of payment. But Bitcoin was like, handle this payment transaction, but in a digital manner. For example, all of us have experienced this innovation now. Like prior to now, some years back, if you want to make transactions with your bank, even to deposit, you have to like go to bank, queue, and do all those stuff. But now, if I ask a lot of us now, when was the last time like you visited, like you walked into a bank, if not for complaints? I know it will have been long that we've encountered that, just because of data innovation. So now applying this, it is now this payment infrastructure that is being carried out on the normal Web2 technology, on normal infrastructure. Let's have this infrastructure on the blockchain, because this blockchain has bring up to like solve a lot of the limitations obtainable with Web2, and it has solved them. So now, since this is a good iteration that, okay, now we can trust technology more. That's why we now have a Bitcoin that was built on blockchain to handle payments. So the limitation of Bitcoin as, this, what's it called? This economic theory or definition that says like human wants are insatiable or something. Sorry, I'm not an economics person, but I think there's something like that. So after like people have used a Bitcoin and say like, wow, this is a fascinating technology. We need, what if we can like build something like thing apart from like just doing payments, something like that can help people to like save money, deposit money, borrow money and stuff. What if we want to build that? We now discover like that was not achievable with Bitcoin, because Bitcoin is not a programmable blockchain. That is what now led to like us having Ethereum. Ethereum was created to serve as the world computer. So it leverages on the decentralized nature of the blockchain to make whatsoever computation power and the things he's doing, it is doing accessible to everybody. So the added layer that Ethereum now brings into place is that it allows anybody to like build on it. So you cannot build any other functionalities on Bitcoin as a blockchain, but you can build on Ethereum. You can build your custom projects, anything, as long as you are writing in the approved smart contract language that blockchain you want to deploy on understands. So that's basically the what I've been trying to explain. Nana, I hope that's clear.
Yes, thank you.
Okay. So before I proceed, does anyone have any question based on what I've explained? Please, yeah.
Okay, we've seen that digital ledgers that are used, they are called distributed ledgers because they act on multiple databases, right?
Not multiple databases. It is one database that's accessible to everyone. Everyone connected there has the same copy. Unlike, like, let's say if it is a centralized system now, sorry, I'm coming. If it is a centralized system now, it is like only one person. Let's say your school record now, it is only like probably your registrar that has access to it, and I say, oh, this person, your name is here, this person, your name is not there. But on a distributed system, everybody there knows what exactly is there and what's not included in that stuff.
I heard about, you were talking about an example of Lagos. you were saying that one can be in Lagos and do some transactions, and then when you move to another city, you do the same transactions on another database, but still the records can be accessed by another database in Lagos. Is that right?
Yeah, that's when you are like, let's say, in terms of like your financial institution now. So I guess probably you're not in Nigeria. So like the banks available to you there now, let's say, I just give me a name of a bank available to you there.
Excuse me. I didn't get that one.
I said, like, give me a name of a bank that you have access to where you are.
Okay, Baker.
Okay, so for example, now let's say Baker is in City A and they also have a branch in City B. If you deposit to your Baker branch in City A, and probably you move to City B to withdraw, to perform some things, and you need to like make use of the bank, what the branch in City B should do is to just check your data that has been stored there and say, okay, you have this in your balance. Yes, you can withdraw this amount and this thing. That's how distributed system works. So it is like different, you know, like they are not in the same location now. There are different branches, but they have like access to the same data. That's how it works. So it's not really different database.
Okay, I get. Thank you.
All right.
So they're actually working on the same database, right?
Yes. In a
So I need to
distributed,
understand that.
so for a distributed ledger, okay, continue with your question.
So I need to understand like what kind of new thing that come with digital ledger, because normally I think that's how things are done on bank systems, either online in Web2. So I need to understand like when it comes to Web3, what's the difference now?
So just like I said earlier, so this implementation of distributed ledger is what is being applied to blockchain. Like if you know the difference, I said all blockchains implement distributed ledger system, but we have different types of distributed ledger system, distributed ledger technology. So depending on the, for example, this hash graph now is a data structure being implemented by software developers to like handle how data are being stored, data are being handled. So like there are a whole lot of stuff. But for the purpose of our class, we are not going to like go into details of distributed ledger technology. You can, that's why I sent this link on the chat. You can use that to like, and just Google search will help you to just understand this if you want to look more into that. I hope that helps.
Thank you.
Okay.
Thank you.
Any other question? All right. So the next one, they're now talking about Ethereum. So in the Ethereum universe, I use universe here because Ethereum serves as a word computer. So there's a single canonical computer, usually called the Ethereum Virtual Machine or EVM, whose states everyone on the Ethereum network agrees on. So because this is a decentralized Ethereum aims to like serve as the word computer. It implements what we call EVM. So this EVM, which is Ethereum Virtual Machine, is what performs the execution of transactions, like all the actions that you want to carry out on blockchain. What executes them is Ethereum, the EVM, sorry. So everyone who participates in the Ethereum network, every Ethereum node, keep a copy of the state of this computer. So that is once you connect on the Ethereum node, using Ethereum node to connect to the Ethereum as a virtual machine, you have access to all the data on that on Ethereum. So requests for computations are called transaction requests. That is, we have something we called write action and read action. For example, now, read action is when you want to like view some of the data stored on the blockchain. So, but write action, that is when you want to update it, you want to add something to the blockchain. Those are called transactions. So like I'm going to let me just say this now for people that might understand. When you want to perform a write transaction on, especially on Ethereum or any other blockchain, you are going to pay what we call gas fees. But if it is a view transaction, that is a read action, you don't necessarily have to pay gas fee. That is it, because there's a lot of computational processes being done when you want to like add something, store something on the blockchain. That is why it's done like that. Please give me a minute, I'm coming. Sorry about that. Can you guys hear me now?
Yes, we can hear you.
Okay, thank you. So now this transaction, once you like send transaction to be added to the blockchain, there are some people we call miners which approve and add your transaction details to the blockchain. So now we need to talk about what is node. Please, how do I check my keyboard history? Okay. So a node basically is any instance of Ethereum client software that's connected to other computers also running Ethereum. So we've talked about Ethereum being the world computer, and allows anybody to like connect to it. So node in traditional world, for example, now let's say you have a network, and for example, we are all connected on Google Meet now. Each system, each device connected to Google Meet now is like a node. So node is like electric devices connecting to a network. But now in relation to like Ethereum, a node is any instance of Ethereum client software that is connected to other computers also running software, Ethereum software. So these nodes are have to, when it comes to like Ethereum now, these nodes have to like implement the Ethereum client. So we have different implementation of Ethereum client, but a node is any instance of those Ethereum clients that's connected to other nodes running Ethereum. So those miners are basically the people that approve transactions. We are going to come into that later as we proceed. So the client is basically an implementation of Ethereum. And this client, what they do basically is verify when you want to like add data to the blockchain. This client, they verify the data you are sending to the protocol so that they can keep the network secure. They need to like ensure that your data, the transaction you want to carry out, follows the rules of that protocol so that you don't mess up the network. Currently, Ethereum is looking at moving from proof of work to proof of stake. That's why I had to put this here, this post-merge Ethereum. So once the post-merge happen, you are going to have two different layers for Ethereum, the execution layer and the consensus layer. Don't worry about that. So we are going to, I know it's a bit confusing because this is our first class, but we are going to like explain as we proceed along. So I will soon stop now, but let me just finish this so that I can take any questions that you guys have. So if you want to run your own node, you should understand that there are different types of node that consume data differently. These nodes are basically when you want to like be like an active like contributor to the chain. That is, you want to be verifying transactions that should be added and transactions that should be rejected. That's when you want to like run your node. So we have three types of node. We have the light node, the full node, and the archive node. What's the difference? The full node, it stores the full data of blockchain, that blockchain that you're currently on. Let's say for Ethereum, for example, now, a full node on Ethereum has the full blockchain data up to the Genesis block. So when it comes to blockchain, each blockchain have something we call Genesis block. Genesis block referred to the first block being mined by that blockchain. So first block is usually referred to as the Genesis block. That's it on that. So, and this full node participates in block validation to verify that all the blocks, the transaction data that were stored in a block are actually correct and can be added to the blockchain. Because, you know, once you perform these actions, once the good thing about blockchain is once a transaction has been carried out, it cannot be reversed. That is why you need to like ensure that you are storing accurate data so that your data can be consistent. And all states can be derived from full node. That is, you can get history of, you can get transaction data of what has happened. Like this is 2022 now. You can get transaction, let's say it's a blockchain that was created around 2015, 2016. You can get some of the transaction data that occurred in 2015 there. So it serves the network and provides data on request. This activates, verify blockchain data and can also like add, when you request for data, full node can also give you response, just like the way your server client architecture works. The next one is the light node. So this light node, instead of downloading every block, light nodes download block headers. And these headers only contain some information about content block. So I want you to like read up about block and how block are being structured. We have something called block header. So the light node can independently verify the data they receive against the safe route. Light nodes enable users to participate in the Ethereum network without powerful hardware or bandwidth required to run full nodes. You should know that when you want to run this full node, you need a very large storage capacity. So, but if you don't have that heavy storage capacity, you can run the light node. It's just that there are different stuff available to you on that. So the next one is the archive node. So the archive node stores everything kept in the full node and built as an archive of historical state. So like this one always like basically archives transactions that are not records that are not usually accessed all the time. So once a blockchain gets extremely large, there are some data that are needed but are not frequently accessed. That's what the archive node helps to like store. So that's it on. We are going to stop there for now. So let me take your question. If you have question, there's something that's not clear about today's class, you can ask. All right. Babatunde Roy Bart.
Okay, good evening. Thank you for the class. So I'm confused. You said about having a public witness or everything being accessible by other network. Is there any form of privacy on blockchain?
A public blockchain, your data are not meant to be private in a public blockchain. That is why you should be, it is not, when you are using a public blockchain now, it is not all, you should not store confidential stuff on a public blockchain because it is easily accessible to everyone. As long as it has been installed on the blockchain, it is accessible to everybody connected on the blockchain. Blockchain, we are going to, although it is not as straightforward as I just explained it, but when you want, there are ways you can like have confidential information, but by default, a public blockchain don't store confidential information there. But if you want to store it, ensure that, let's say it has gone through like this cryptography, different encryption model, and you are not just storing the direct confidential information on chain. That's it.
Okay, thank you.
All right. Charlie, you can speak.
Yes, good evening. Please, talking about the privacy that Babatunde just mentioned, I want to understand something.
Okay.
Like I want to say what I understand, sorry, and then you let me know if it's actually correct, if what I understand is correct. So I remember you talked about people who are in a particular network can have access to information stored on the blockchain network. All of them can see that information.
Yes.
So does it mean that that particular network could be like a, how will I put it, like a community of people who are trusted, who trust themselves enough to actually have that decentralization to maybe, let's say for instance, here, this class where we are in is a network, and everybody on here, their names, Peace, Jolade, all of us, how we have like our names and our home addresses stored on this blockchain network that all of us can see clearly. But is there a way that people outside this our particular network cannot have access to us here, despite the fact that all of us here can see what we are all doing? People outside, they cannot see it because somehow we have found a way to privatize the whole blockchain. I don't know if it actually makes sense the way I'm saying it, Sha.
Okay. That's why we also have private blockchain. We have private blockchain, but in a public, also note that like when I'm saying like you're adding stuff to it, know that every transaction, every details is actually encrypted using the cryptographic hash. It is not stored that, let's say you store this thing, let's say your name on the blockchain now, your transaction details will contain the hash. But because cryptographic hash is deterministic, people can query it, and for confidential information that you want, for example, now we have IBM, we have different organizations that are using blockchain to handle their company data. Those ones you can have a private blockchain handle that, and that way you like restrict access to people that have access to it. It's not accessible to everyone, depending on the architecture on which it is built. Yeah. Shirley, does that answer your question? Or is it clear now?
Not really. I think I'm just going to read about it. I don't know.
Okay. In case it's not still clear, you can drop your question as you proceed on the Slack channel after.
Okay.
I know, like, if probably like this your first encounter with all this blockchain stuff, I know it can really be overwhelming and it might be confusing now, but just try as much as possible to ask questions so that you can get clarity on whatever it is that's not clear.
Yes, thank you so much.
All right, you're welcome. Matilda.
Okay, good evening. Thank you so
Good
much for
evening.
this class. My question is, what are
I can't hear you. Matilda, if you are speaking, I can't hear you.
examples of public blockchain, like you mentioned, that you said?
I think Matilda is having network issues. Maybe when she's back. If your sorry, or can anyone hear Matilda? Okay,
No.
we could not hear what you were saying.
No.
Matilda, I did not get your question. So I think maybe you're having network issues or something. Yeah, I can hear you now.
Me now? Okay, I said, can you please give an example of a public blockchain where we are supposed to store private information or important information? I'm not clear on that. Can you please give an example of a public blockchain and also an example of a private blockchain?
So private blockchain, you have like the IBM stuff, IBM blockchain itself. So, but the public blockchain, when I say like don't store private information, it's private information varies. It depends on this thing, but you should know that anything you like deploy on blockchain is actually accessible. Anybody can see what you store. So now depends on like what you are storing. For example, now let's say it's a will. Depending on the architecture of the there are different ways to like make it like a bit secure. That is not, but you should know that if it is deployed on a public blockchain, it is accessible. Anybody can read what you've stored. So example of that is you have Ethereum, you have Solana, all the other blockchain that you have, or majorly all the blockchains that you are familiar with are public blockchains. Matilda, is that clear?
Okay, so sorry.
All right.
A supporting question. So like these are private keys to our wallet. Does it mean other people can also have access to that private key?
No. Your private key is not accessible to everyone. What I'm saying is like, for example, now all I look at what I'm sharing my screen now. So like look at it. You know, like when your what's it called? Your bank history now. I can't say, I should not be able to like say, oh, Matilda, you transferred 10,000 to this person at so date. It's not as available like that with your bank record. But like look at it. This is Etherscan. This is like the blockchain explorer for Ethereum itself. So now let me just look at any of these transactions. This transaction was carried out 59 seconds ago. So here's where the twist now come in. In blockchain, you are not being noted by your name. You don't need KYC You're not storing your name, but you can know that, like for example now, this transaction was created from this address. So this address, the address that started this transaction currently has $61 in his account, but I don't know who this person is, and I can't guess who the person is because this is just the only thing I know about this person. It's just that this is the address that initiated this transaction. And what's the details of the transaction? Let's see. From this address to this address, this is the transaction fee the person paid, and this is an EIP transaction. That's just it. So for this, not a for example now, when I say like your informations are public, it's not like directly that when it is on blockchain, they can tell that this transaction was carried out by Matilda. No, it is that they can just say this address associate this public address, which is like this one now. Looking at this, you don't know who this person is. We don't even know how the person looks like. Is he a lady, is he a guy, or anything? But we just know that this transaction was carried out by this team. And the person that owns this transaction in this account, what they need to control it is just their private key. Is that clear, Matilda?
Yes, it is. I understand now. It's just like NFTs too, how we see who mined the project, who bought this from this person, but not the person in particular. We can see their addresses, the amount they bought it, and the time. Nothing more than that.
Exactly. So like NFT is still like applications of blockchain. So that's just it.
Thank you very much. I understand now.
You're welcome. Informer.
Okay, thank you, Mr. Devayo, for the class.
All right. Okay, I'm actually Abimbola. My surname is Adebayo.
Okay, Mr. Abimbola. My question is, throughout the history of this blockchain, this public blockchain stuff, have there ever been like cases of privacy infringements? I don't really know how to put it, but like, since it's like public, have there ever been issues of let's say like fraud? And if there ever has been, what measure has been taken to handle that breach?
Okay, there are several issues of fraud. For example, now, if you look at the block explorer that I showed you, we just know that this address carried out that transaction, and the address has like $61 in it. The only way you can perform action on that account is if you have the private key. You know that you are not doing KYC. You don't know the person name. We don't know how the person looks like or anything about the person. The only thing that the blockchain understands as the valid signature for that account is the private key. And if for any reason you by having your private key, there's no way anybody can get your by using your address, your public address that's accessible to everybody. Let's say, like a public address in this case now, when someone wants to send you money with your bank account now, you send them your account number. So the account number that you send to is like the public address. That's where what people use to like interact with you and stuff. So this public address is what they now send money to. And with this public address, nobody can actually get your private key. So because of the implications of this, there are several ways whereby people can lure you to like give them your private key. So that's just how it is on that. If I'm up, hope that's clear for you now.
Yeah, it is. But like you gave an example of account number. If I give someone my account number and the person wants to run a transaction, it gives out my name, and somehow they can use that information to get some information about me, further information about me. So if you're saying it's like similar to a public address, are you saying that there's no way they can trace it back to me to know that, oh, I'm Chioma
On a
Okoha?
on a decentralized network, no way.
Okay.
The only somehow way is if you link your address to ENS. So now let's say on Ethereum now, and you now say your address is ifeoma.eth, and everybody around you know that you are ifeoma.eth. Yes, they now know that, okay, Ifeoma, that is ifeoma.eth, is the owner of this account, and you can change it anytime. That's the only thing, but they can't like perform any action on your behalf unless you approve them.
Thank you so much, sir.
All right, you're welcome. Jolade.
Thank you. Thank you once again. So there are two things I actually want to talk about. So I want to co-ask and probably buttress more on Charlie's question the other time. So when she was asking her question, I think what she meant was, Ethereum, Solana, BNB, and all of these are blockchain network, right? And it's decentralized, so everybody can access it. So what she's saying is that if I use Solana and you, for example, use Ethereum and another person uses BNB, can we all access each other's information, or it has to be Solana to Solana, like we're using the same network, then I can access for example, I can access your information, transaction details, and all, since it's on blockchain.
For
Does it
example,
have to be network to network, or as far as it's on blockchain, you can access any network at all?
Here is it. If you are talking about like reading transaction now, it is accessible. For example, now I come to Ethereum, this Etherscan now. This Etherscan, I'm seeing all the transaction available on Ethereum. So let's say if it is on Solana now, you can see that I not connect my account now. If it is to read what has been stored on the blockchain, good and fine, you can read anything. So let's say I want to read, I don't know Solana, this, let me just search for you. Solana Block Explorer. Okay, use it. So this is the one for Solana currently. These are the transactions on Solana currently. Okay, let me use source scan. I think it should be source scan. So this is the one for Solana now. These are like transactions carried out on Solana currently. If I want to check on Polygon, what I just do is come to Polygon scan. Polygon scan. So this is how it works on Polygon. So if it is to read something that has been stored, you can access it anywhere. Is that clear?
Okay, very, very clear now. I hope it's clear to Charlie as well. Thank you. So the second thing is, I just want to talk briefly about I don't know, I forgot who asked that question, the fraud, the privacy stuff. Can I go ahead?
Yes, you can go ahead.
Okay, thank you. So there was this time I was trying to find my way around all this whole stuff, and then I didn't know I had like 0.0025 BNB in my account, but I was using testnet to write this particular app, right? But because I was using build space to try it out, and then I saw that I'm supposed to use ENV to like protect my private key. There's public key and then there's private key. So I was confused, and then I pushed the two, like I pushed everything. I inputted it on my code, and then I pushed it to GitHub. So I realized later, and then I deleted it. But because it's already stored on GitHub, before I know it, like after a few days, that money just disappeared. Like it just showed me that on this day this money was moved from your account to so address. So that was the only information I got. It is not traceable. I think I was the one careless at that point, right? So it is not traceable, nothing. It is only the address I see, and you know, a lot of transaction has been performed on it. So I was unable to actually do anything. Also, I don't know if there's privacy at all in this in all of this decentralized this thing, because if you just look at and put your private key out there, anybody can actually have access to your account. So I'm trying to add to the question or add answers to the question she asked. Thank you.
Are you still using that account?
No. I deleted it. And then I had to create another one. And I've been so scared since then. I don't even want to touch it. Like I've not even go to the whole address and anything since then. Even my own personal.
Nice one. So let me see you. It's good. Like we have someone that has experienced this, that's sharing our experience. Since you guys will be doing some things on this thing on smart contract development, when you are using your private key to perform actions and you want to push your GitHub, ensure that you have your private key in your .env file. Your .env file, anytime you want to like perform actions, will not be pushed to GitHub. Because GitHub is public, especially when you're pushing to GitHub, a public repository on GitHub. The thing is, because everybody now knows that private key is valuable, there are a whole lot of bots monitoring GitHub. For example, the moment they just those bots know like the length of a private key, they just check if they see anything that relates to like private key, they just test it out. If it works, and they move everything that is there and perform whatsoever. Like, because we now know that this thing, your private key is what serves as the master key to your account. That is why you need to like guard your private key seriously. Don't push your private key to GitHub. If anybody has access to your private key, they have access to everything you have in that account. That's it on that. I think that's Jolade, right?
Yes, please. Thank you.
Okay, thank you. Romola, you can ask your question.
Okay. My question is on NFTs, and I just want to ask that things you said, like, because we're talking about blockchain privacy, and then you're saying blockchain technology and ETH is public and accessible to everyone in the network. Yeah. So how then, like, is an NFT unique to the owner? I mean, like, what's that thing that makes an NFT? Because I think NFTs are like apps built with it, and not apps, but like fungible tokens, non-fungible tokens built to ETH. So, like, how is it unique to the owner? Like, what's the thing that makes it private to the owner? I don't know if I'm asking correctly. See, the data stored on
the data is stored on blockchain. I get. I'm not supposed to go into this now so as not to confuse everybody, but I'm going to answer your question. So we have fungible token and we have non-fungible token. So NFT is a non-fungible token. What that means is that it is unique. For example, now fungible token is like, let's say I want to withdraw 50,000 now, and I say everybody in this class, let's say, okay, let's just look at it. We have 38 people in this class, and I want to share 38,000. What I have with me is 1,000 naira notes in 38 pieces. If I share it with everybody, we all know that nobody is cheating anybody. We all have the same amount. But that's not how NFT work. Each piece of NFT is unique. So NFT has something called storage. Those arts are not directly stored on chain. They are stored on decentralized network, decentralized storage, such as IPFS. So it is now the token URI. When you store it on a decentralized storage, they give you something called token URI. So it's that token URI, which is the hash It's like just like Google Drive. Now, when you upload something on Google Drive, you have a Google Drive link generated for you. So like this hash is what points to like the location of that NFT stored on the decentralized storage. So what you are now doing is how you are now referencing it on blockchain is making sure that this stuff that was stored on this social network, it is only one piece. So this one, everybody now knows that, okay, for this R2, it is just one. Is that clear, Romola?
Yes, I am. Yeah,
Okay.
so,
Okay. You're welcome. Informer.
Okay, thank you very much, Abimbola. I was just wondering, since like what's the essence of, like, we're talking of like a public blockchain, a private blockchain, and all of that. And on the public blockchain, certain things are, certain information is public to everyone, just like the example you gave about the person who has $1 on his account and all. And I was just wondering, what's the essence of now like publicizing some of all this information? Like, what's
The
the essence?
essence is that we are not having a centralized authority handling all these things for us. So in this case now, in a blockchain, see that like the participants, the users are actually the people maintaining it. So and look at it now, when we're checking on Etherscan, the only thing we could see, it is a public blockchain. It is private in the sense that everything is encrypted using cryptographic hash. All you just have to, as the access to an address is just those number. You can't tell that this address belongs to Informer, this address belongs to Romola, this address belongs to so person. So that's why you have it. It is to make it that you can tell that what you have, this is what you get, this is what is accessible to everybody. For example, now, if it is not like that, for example, you have used Facebook before, and you've heard about like different issue of like Facebook selling your data, doing this thing and that, and different companies like using your data against you. Those ones have been solved by blockchain because yes, it is public, but everything, it is not linked to a person. You can just say, this is the total amount in this protocol, but you don't know who the person is. That's the good thing about it. It is public, but not directly linked to someone. That's it. Romola, is it Romola or Informer? Is that clear now?
Yes, it's clear.
All right, thank you. Osarese.
Okay, hi. With what you just explained now, can transactions be traced, whether be public blockchain or private blockchain? Can transactions be traced back to a person, in the sense that some persons use this blockchain technology for criminal stuff and all of that? So how do you trace it back?
If it is carried out on a fully decentralized platform, you cannot trace it. Just like I think it was Jolade that said our account was she made a private key public. sorry, I'm not supposed to laugh, but like our private key was now public, which is not supposed to be, and that person accessed, like, moved the stuff. She know that, okay, this is the address that moved the account, but she cannot tell that this is the person.
Okay.
So in that case, if it's on decentralized platform, you cannot trace it.
Then it's actually a disadvantage, right?
It's not a disadvantage, because when you want freedom, there's something called when you want freedom, you also have to like attach responsibility to it. When you are saying that I'm not allowing Facebook to access my data, I want to be responsible for my own data, it means that you are holding yourself liable for anything that happens there. the blockchain has made it possible that nobody should be able to access your account unless you expose your private key. So if you expose your private key, you know what will happen. That's just basically how it is.
Okay.
So that's it. So like as we are going to be like doing a lot of development, you guys should take note of that. Any account, see, that's why most of the time when you are creating your smart contract, your account, it's usually being said that store your private key offline, so that in case like probably someone gets access to your phone, they don't, or phone or system, they don't just get access to that account and stuff like that, because that's your master key. So you need to like protect it judiciously. Yeah. Shally.
Hi. Okay, I just wanted to add about the privacy and whatnot, and like not being able to trace transactions and all of that. And I feel like it's just the price we have to pay if we want the sole authority, like if we want to receive power back as users of
Exactly.
this whole internet, whatever. Because this whole Facebook, Twitter, all these big tech organizations that have our private details, like when we log on to Twitter, we've already given them sometimes our email addresses, phone numbers, all those kind of things. We don't even know what they're using this data for. We don't know who can come from the dark web to fight us, to attack us. You know, I'm just saying that when we entrust these big tech companies with our private data, we don't know what they're really doing with it. So I feel like if we are moving into the Web3, we should know that we are taking power back, but it has to come at a cost. And I feel like the cost is this whole not being able to trace someone down to their homes. Maybe someone steals money or something, you will not really know who stole it. So just be careful.
So
yeah,
thank you. With responsibility comes, with freedom comes responsibility. Just take it to your part of your to-do tasks. I need to like be held accountable for this thing. So to add to what Shadi said, a lot of us have like signed up on different platforms and they say, do you accept it our terms and conditions? And just click yes. Did you actually read the terms and conditions? A lot of us will not read the terms and conditions. I just say, okay, yes, accept. And with that, you are giving them full access to do anything. And you cannot sue them because you signed it. That's it on that. So, Bolaniwa, I think you have a question.
Yes, good evening, thanks for the lecture. So my question is, if you are not very proficient with backend Web2 development, hope that is not an issue for the features or for the functionality you'll be building on Web3. Like, is there like,
Have you been coding before now?
Yeah, those front ends, sir.
As long as you can code, don't worry, we'll explain everything. It's just that the truth is, to be truly good, these 4 weeks will not be enough. If you want to like go into deep of this smart contract. So, but you'll be able to like get the foundation run. For example, you that's doing front end now, if I ask you, I know it's definitely 4 weeks that you've been practicing front end. It's been more than that. So it's the same way. This is a skill that you need to like keep improving on. That's just how it works. But anyway, exactly.
Yes.
Okay, thank you. Is there any other question? So just to add, please try as much as possible to go through the material shared with you. There are a lot of things you need to learn, and trust me, within these 4 weeks, if you want to make good use of it, is read as much as possible so that when you have a question, you can easily get answers to them, because you are going to have a lot of questions. That's the truth. So that's it. And in case you have any issues, you can tag me on Discord. Sorry, I mean Slack. Yeah. So Ose, you have a question?
Yeah, thank you so much for the class. I really like to know if you share your notes with us after today's class. Because I think I went to the material shared already this afternoon, and if I am correct,
Yeah, the
your
slide
notes
is
were
not
not
there.
there.
Yeah, the slide is not there. So I think that will be worked out. It should be shared with you guys.
All right, thank you so much.
All right. So in the absence of that question, so you guys should also talk about what you've done, talk about today's class on Twitter, but besides yourself, okay, I'm going to drop my Twitter handle on Slack. So you can drop your review about today's class, tag me on Twitter. Let's learn in public. Let's do it that way. Okay, so that's it for now.
Hi,
Any
Abimbola. Sorry.
Yeah.
So
Okay.
sorry. Sorry, I left a
No
question
problem.
in the chat. Sorry, I interrupted.
No problem. So okay. Node. Okay. Just see it like node in normal terms is like you have a device now connected to this meeting and you're accessing it. You can hear me. Everybody has this their device connected to Google Meet. That's why we are connected to this link. That's why we all can like talk and hear me. So what you need to do, what node just basically means is in this context now is a device connecting to a network. Is that clear thing?
Yes.
Okay. That's just the basic meaning. So that's it. Any other question, anybody? I hope today's class was helpful though. So you guys should, let me stop recording. So we see, and if you have any question, please drop it on Slack so that everybody can learn together and I will respond once I see it. All right, take care everybody.